looking up at the sky and seeing your world about to end. Not with fire from volcanoes, not with ice or famine, but with something far older than Earth itself, a silent traveler from the edge of the solar system, falling inward for millions of years, unnoticed until it was far too late. 66 million years ago, not 60, as we often rounded, Earth was thriving. Dinosaurs ruled every continent. Oceans were full of life. Forests stretched endlessly, dense and humid. To any observer, this was a stable, ancient world. But stability in the universe is an illusion. Far beyond Neptune, in the dark outskirts of our solar system, lies a vast reservoir of frozen debris, remnants from the formation of the planets. Occasionally, something disturbs this distant region. A passing star, a subtle gravitational shift, a chain reaction set in motion millions of years earlier. One such disturbance sent a massive object inward. At first, it was just another piece of rock and ice, tens of kilometers wide, drifting through darkness at unimaginable speed. It didn't glow. It didn't announce itself. It simply followed the laws of gravity, accelerating as it fell toward the sun. As it crossed the orbit of Jupiter, everything changed. Jupiter, the giant guardian of the solar system, often shields Earth by capturing or deflecting incoming objects. But sometimes its immense gravity does the opposite. It can redirect a wandering body, slingshotting it inward with even greater speed. That may be exactly what happened. The object's path shifted. Its velocity increased. What was once a distant threat became inevitable. And still, on Earth, nothing new. Dinosaurs continued their routines. Predators hunted. Herbivores migrated. The skies were filled with flying reptiles. Life moved forward, unaware that high above a cosmic clock had begun its final countdown. Days before impact, the object would have become visible, a bright point in the sky growing larger each night. Brighter than any star, possibly visible even during the day. What would they have seen? A second sun, a burning scar across the sky? We don't know, but we do know this. By the time it became undeniable, there was nothing anyone or anything could do. And then, the final day arrived. The final hours did not begin with chaos. They began with light. Long before the object touched the Earth, it entered the upper atmosphere at a speed of more than 20 kilometers per second. The air in front of it compressed violently, heating to thousands of degrees. The sky itself ignited. For a moment, just a moment, the planet had two suns. Across what is now the Yucatan Peninsula, the horizon would have blazed with an intensity no living creature had ever witnessed. Shadows vanished. The air shimmered, and then faster than the brain could process. Impact. The energy released in that single instant exceeded billions of nuclear explosions combined. Rock did not simply break, it vaporized. The ground behaved like liquid under unimaginable pressure. A crater nearly 200 kilometers wide began forming in seconds. But the impact itself was only the beginning. A shockwave tore outward at supersonic speed, flattening everything in its path. Forests were erased. Creatures miles away were thrown through the air like dust. The atmosphere itself rippled as the pressure wave circled the globe. Then came the heat. Debris ejected into space began falling back to Earth, not gently, but as a rain of molten fragments. As they re-entered the atmosphere, they heated the sky to oven-like temperatures. Entire regions may have ignited simultaneously, as if the planet itself had been placed inside a furnace. This was not a single disaster. It was a cascade, Mega tsunamis, hundreds of meters high, raced across oceans. Earthquakes triggered by the impact shook the crust for hours, possibly days. Volcanoes may have erupted in response, adding even more ash and gases into an already darkening sky. And above it all, the sun disappeared. Dust, soot, and aerosols were thrown high into the atmosphere, blocking sunlight. Within days, temperatures began to fall. Photosynthesis halted. Plants died. Food chains collapsed, one layer at a time. This is what scientists call an impact winter. But that phrase barely captures the scale. Imagine a world where daylight fades into a dim twilight, then into darkness, where temperatures drop globally, where survival depends not on strength, but on adaptation, on being small, hidden, and able to endure. The age of giants was ending, not instantly, not in a single day, but irreversibly. And yet, here's the most unsettling part. This was not a unique event in cosmic history. It was just one moment in an ongoing story written across the solar system. To understand why this happened, we have to leave Earth behind, because the story of the dinosaurs' last day does not begin on our planet. It begins in the architecture of the solar system itself, a dynamic, restless structure shaped by gravity, chance, and time. Beyond the orbit of Neptune lies a vast region known as the Kuiper Belt, a scattered disk of icy remnants left over from planetary formation. Even farther still, stretching nearly halfway to the nearest star, is the hypothetical Oort cloud, a spherical halo of trillions of objects loosely bound to the sun. These regions are not static. They are constantly influenced by forces far beyond our immediate neighborhood. Passing stars, galactic tides, even the slow oscillation of our solar system as it moves through the Milky Way. Each of these can nudge distant objects just enough to send them drifting inward, toward the inner planets. Most never reach us. Many are captured or destroyed, but some slip through. And when they do, their journeys are measured not in days or years, but in millions of years. A single gravitational interaction, far out in deep space, can set a collision course that unfolds across epochs, long before life on Earth senses any danger. In this sense, the extinction of the dinosaurs was not a sudden accident. It was the final step of a process that began in deep time, far beyond human imagination. But there's something even more unsettling. We often think of Jupiter as Earth's protector, a massive shield that absorbs or deflects incoming threats. And in many cases, that's true. Its gravity captures countless comets and asteroids that might otherwise cross Earth's path. Yet gravity has no intention, no preference. Under the right conditions, Jupiter can transform from a shield into a slingshot, accelerating objects and redirecting them inward with deadly precision. Simulations suggest that without Jupiter, Earth might actually experience fewer high-energy impacts from certain regions of the solar system. In other words, the same force that protects us can also endanger us. The Chicxulub impactor, the one linked to the Extinction event, may have followed such a path. Nudged from a distant reservoir, redirected by giant planets, sent inward on a trajectory that intersected perfectly with Earth's orbit at exactly the wrong moment. A cosmic coincidence, or an inevitability, because in a system this vast, with so many moving parts given enough time, collisions are not rare events. They are guaranteed. And that raises a question that is far less comfortable than anything we've discussed so far. If it happened once, could it happen again? Today the sky looks calm. The sun rises and sets with predictable rhythm. The moon follows its silent path. The stars appear fixed, eternal, unchanged from night to night. It feels stable, safe, but that sense of safety is deceptive. Right now, thousands of objects are moving through the solar system on trajectories that we are still trying to understand. Some are cataloged, tracked carefully by telescopes scanning the sky every night. Others remain unknown, hidden in darkness, too small or too distant to detect you for now. These are known as near-Earth objects, asteroids and comets whose orbits bring them into proximity with our planet. Most pose no threat. A few are classified as potentially hazardous, not because they are on a collision course, but because their paths intersect Earth's orbit in ways that require careful monitoring. Space agencies around the world are watching. Modern surveys have identified tens of thousands of asteroids. Sophisticated models project their orbits decades, even centuries into the future. Missions have already tested our ability to alter the trajectory of a small asteroid. A subtle push, delivered years in advance, that could prevent a future catastrophe. For the first time in Earth's history, a species has the awareness, and perhaps the capability, to defend itself against a cosmic threat. But there are limits. Objects like the one that ended the age of dinosaurs are rare and difficult to detect early, especially if they arrive from the outer solar system, where sunlight is weak and warning times are short. A large comet, approaching on a long period orbit, might only become visible months or even weeks before impact. In cosmic terms, that's no warning at all. And then there is the question of scale. Deflecting a small asteroid is one thing. Stopping a mountain-sized object traveling at tens of kilometers per second is another entirely. The energy involved is almost beyond comprehension. Even a slight miscalculation could turn a near miss into a direct hit. So we watch, we calculate, we prepare, because the lesson of the dinosaurs is not just about extinction. It is about awareness. They had none, we do, and yet awareness alone does not guarantee survival, because the universe is not designed with us in mind. It does not adjust its course. It does not offer second chances. It simply follows the laws of physics. And somewhere, right now, in the cold darkness beyond the planets, there may already be an object on its way. Not aimed, not guided, just falling. There is a place on Earth where the end of the dinosaurs is written into the ground. Beneath the Yucatan Peninsula, buried under limestone and jungle, lies the Chicxulub crater, nearly invisible on the surface, but unmistakable in its structure when seen through gravity maps and seismic imaging. A circular scar, almost 200 kilometers wide. A frozen record of violence from deep time. But what makes this site truly remarkable is not just what it shows, but what it preserved. Within layers of rock around the world, scientists have found a thin band of clay dating precisely to the end of the Cretaceous period. In that layer, iridium, an element rare on Earth's crust, but common in asteroids. It is the fingerprint of an extraterrestrial impact, a global signal, a moment when Earth's geology briefly recorded something from space. After the impact, life did not disappear entirely. It retreated, adapted, survived in the margins. Small mammals, once overshadowed by giants, suddenly found ecological space to expand. Birds, descendants of certain dinosaur lineages, persisted. Deep ocean ecosystems endured longer than surface ones, buffered by the water above them. The world, however, had changed. Forests regrew slowly. Climate patterns stabilized over thousands of years. The sky cleared. Sunlight returned. But the age of dinosaurs was over, not because they were weak, but because the system they lived in included forces they could not perceive. Today, we live in that same system, and yet something is different. We are no longer blind to the sky. We map it, we model it, we send spacecraft to touch asteroids directly to measure their composition, their structure, their behavior. We have even tested what happens when we intentionally alter the path of a space rock. A small but significant demonstration that the future does not have to mirror the past. Still, the scale of time remains humbling. The same gravitational mechanisms that sent the Chicxulub impactor inward are still operating. The same distant reservoirs still exist. The same galaxy still passes through interstellar environments that can disturb them. Nothing has stopped. The solar system is not static. It is an evolving gravitational ecosystem, and Earth is one of its participants, not its exception. So when we look at the night sky, we are not just looking outward. We are looking into a system that has already rewritten life on this planet once, and is fully capable of doing so again. The only variable now is time and awareness, because the dinosaurs never saw it coming. But we are still here, watching, learning, waiting for the next move of a universe that does not announce its intentions. If you could rewind time to the moment just before impact, there would be no warning sirens, no final message from the sky, no cosmic announcement, only a point of light growing brighter with every passing hour. That is what makes impacts like Chicxulub so unsettling. Not their violence, but their silence. Space does not send intent, it sends trajectories, and trajectories do not care about what lives beneath them. Today, we often describe Earth as safe from the kind of catastrophe that ended the age of dinosaurs. Statistically, that is mostly true. Impacts from objects of that size are rare on human timescales, separated by tens of millions of years. But rare is not the same as impossible. In fact, the solar system still contains the same ingredients that produced that event. The same reservoirs of comets, the same asteroid families, the same gravitational interactions that slowly reshuffle orbits over vast periods of time. The difference now is not the sky, it is us. We are beginning to build a kind of planetary awareness, a system of telescopes that scan the darkness every night, mapping motion against motion, searching for anything that does not belong. Some of these surveys are so sensitive they can detect objects only a few dozen meters wide across millions of kilometers of space. And yet, even with all this technology, there are blind spots, objects coming from the direction of the sun, dark bodies with no reflective surface, long-period comets entering the inner solar system for the first time in millions of years, moving too fast, too late, too close. The universe does not optimize for our comfort. It only evolves probabilities. But there is something profound happening in response. For the first time in Earth's history, we are testing ways to physically alter the path of celestial objects. Not in theory, but in practice. Small spacecraft, precise collisions, measured deflections. The idea that a rock drifting through deep space could be nudged just enough to miss an entire planet. It is a strange kind of moment in history, a species that once looked at the sky in fear, now reaching into it with intent. And yet, even this does not change the deeper truth revealed by the dinosaurs' last day. The universe is not hostile, it is indifferent. The asteroid that ended their world was not aimed. It was not chosen. It was simply one outcome among billions of gravitational possibilities. A path that intersected Earth at exactly the wrong moment in deep time. And if you extend that logic far enough, you arrive at something quietly humbling. Earth has always been living on borrowed stability, a temporary calm inside a moving system. So when we imagine that final day of the dinosaurs, it is not just a story about extinction. It is a story about timing, about chance, about a planet caught in the middle of a cosmic mechanism that has been running for 4.5 billion years and will keep running long after us. The sky above us is not empty. It is active, and somewhere, far beyond what we can currently see, the next great rearrangement of that system may already be underway. Not as a threat, not as a promise, but as physics, waiting for its moment to arrive. And when it does, there will be no announcement, only light. There is a strange idea that comes up again and again in planetary science, almost like a quiet refrain. Earth is not separate from the solar system. It is part of its machinery, not a passive passenger, but a moving component inside a gravitational network that is constantly shifting, reshaping, and redistributing energy across billions of kilometers. And in that network, nothing stays fixed forever. Orbits evolve, resonances build and break. Objects are nudged, slowly at first, then suddenly. The dinosaurs lived inside that system for over 160 million years, longer than humans have existed by a factor of more than 1,000. And for most of that time, nothing extraordinary happened on a global extinction scale, which is exactly what makes the Chicxulub impact so important. It was not part of a regular cycle. It was not predictable in any meaningful human sense. It was a statistical inevitability that arrived at a very specific moment in Earth's history when complex ecosystems had reached a particular configuration of vulnerability. A single object, tens of kilometers wide, intersected with a rotating world of oceans, continents, and atmosphere, and the outcome was global transformation, not because Earth was fragile, but because energy does not negotiate. It transfers, it redistributes, it reshapes everything it touches. And after that event, the rules of dominance on this planet changed completely. Large-bodied reptiles, once the undisputed rulers of terrestrial ecosystems, disappeared. Mammals, previously small and nocturnal, began expanding into new ecological roles. Over millions of years, this shift eventually led to entirely new branches of life, including primates, and eventually, us, in a very real sense. The impact did not just end an era. It redirected evolution. But what is often overlooked is this. The same gravitational environment that allowed that impact still exists today. The asteroid belt between Mars and Jupiter is still being stirred by resonances. Comets still drift inward from the outermost edges of the solar system. Galactic tides still subtly influence distant icy bodies. The system is still active, still dynamic, still capable of producing rare, high-energy intersections. We often think of extinction events as ancient history, locked behind a line in time that separates then from now. But in cosmic terms, there is no such boundary, only intervals. Oh, and those intervals are not guaranteed to remain empty. So when we study the last day of the dinosaurs, we are not just reconstructing a past event. We are examining a mechanism that does not remember what it has done before and does not hesitate to do it again. The sky above us is the same sky that once carried a fire across the horizon of an ancient world. And if you wait long enough for orbits to shift, for alignments to occur, for probabilities to converge, that sky can still change. Without warning, without pause, without regard for what lies below. There is a moment in every extinction story that science can describe, but never truly feel. It is the moment just after everything changes, when the energy has already been released, when the physics has already done its work, and when the planet itself is left to deal with the consequences. On that ancient Earth, the sky would have been wrong in a way no living creature had ever experienced before. Not just dark, but sealed, sunlight reduced to a dim, scattered glow, a world lit more by memory than by stars. And yet, even then, Earth did not stop. It adjusted. This is the part of the story that is often missed when we talk about catastrophes from space. We imagine endings. The planet does not think in endings. It responds in transitions. The dinosaurs did not vanish in a single instant everywhere at once. Some regions collapsed immediately. Others endured for longer, buffered by oceans, geography, and chance. But the global system they depended on, climate, food chains, light itself, had been fundamentally disrupted. The line between survival and extinction was not drawn by strength. It was drawn by timing and by position on a rotating world inside a moving solar system. Because what happened 66 million years ago was not only an impact on Earth, it was a collision between Earth and the architecture of space. A reminder that planets are not isolated stages for life. They are active participants in a larger gravitational story that stretches across billions of kilometers. Today, we look outward with instruments the dinosaurs could never have imagined. We map near-Earth space. We track invisible trajectories. We send probes into the paths of ancient rocks, trying to understand their structure not from a distance, but from within. And still, the deeper truth remains unchanged. The same mechanisms that delivered that ancient impact are still operating. Quietly, continuously, beyond human attention, but not beyond physical law. The solar system is not finished writing its history. It is still unfolding. So when we ask what the last day of the dinosaurs looked like, the answer is not only found in geology or fossils. It is found in motion, in a rock that began its journey far from Earth, in gravitational nudges that accumulated over unimaginable time, in a final alignment that required no intention, only inevitability, and perhaps the most important realization of all. Earth was never promised continuity. It has only ever had probability, a window of stability inside a much larger and different system. The dinosaurs lost that window. We are living inside it, for now, because somewhere in the darkness beyond the visible planets, objects are still moving, slowly, silently, following paths shaped long before any observer existed to witness them. Most will pass harmlessly, some will not, and the universe will not mark the difference. It never does. It simply continues, until gravity, chance, and time intersect again, and another world looks up at the sky, without knowing it is about to change forever.